Today class is transport number. Transport number that we represent either K plus per cadence or T minus per NH. So before we start this topic transport number, we are familiar with this. Let's say if I have the electrolytes, let's say NaCl, and I have electrodes, inert electrodes I have. So we know that production of current is due to movement of ions. Let's say for NaCl, this Na plus plus Cl minus. So these are the ions. If these ions moves, then due to this movement of these ions, current will be produced. So in this electrolyte, Na is there. So here Na plus Cl minus Na plus. This ions is there. Whenever you connect the current, whenever you connect with battery, let's say this positive and negative part of the battery, then this is called negative and this is positive, and this is anode and this is cathode. So this is minus and this is positive. So these ions will get attracted to the respective charges. So here Cl minus means it will attract towards anode, and this positive charge will get attracted towards cathode. So while these ions moves to their respective electrodes, so whenever these ions move, then due to this movement of ions, current will generate. So I can write due to movement of ions, let's say either Na plus or Cl minus, for these electrolytes, the current will produce. So if the ions, so due to movement of ions, the current will produce. It means what I say is that if the ions will move fast, then more current will produce, and if the ions will move slowly, let's say this Na is there, with Na, if this is water solutions, if this is water solution is there, then with Na water molecule is also there, so it is Na sphere will there, that we already discussed. Na plus with water sphere will be there. So with that, it has to move towards the respective electron. Let's say Na, it has to move cathode. So how much speeds it is able to do to reach that cathodes? So that speed, if it is high speed, then more amount of current will produce. If it is less speed, then less amount of current it will produce. So I say if ions will move with high speed, then high current or is more current will produce. More current will produce, and vice versa. If less, then less amount of current will produce. Okay, so and previously class we have discussed it means that current productions will depend on the ionic mobility. It means current. Ionic mobility means the movement of ions, how speed or how slow the ions is moving. So current productions depends on ionic mobility. Now, okay, so these points you remember. So I'm just erasing. I'm just going to give that another points. So previous class we have discussed that if, let's say, if ions are Li plus, Na plus and K plus is there, and if solution is at aqueous solutions, then what is the speed of the ions? Let's say first I will talk about of the crystallography size. So for crystallographic size, which is more? So lithium is smaller. Yes, lithium is smaller. Na is more than for size. Lithium up to that Na, then K plus. And for that, if you say about of that hydrated radii, then say if Li has small size, then more water will get attracted, because density is less means more water will get attracted, and then after the water attracted to Li, then it hydrated Li become bulkier than Na, then K plus. So hydrated Li, for that case Li is high size, after that Na, after that K plus. Then the ionic mobility, so ionic mobility is inversely proportional to size. So this is high size, then ionic mobility will be opposite to that. So this is the ionic mobility size. So here that if high ionic mobility, then high current it will be able to produce. So current production, which has more, the same way. Okay. Now, so why I am discussing these things? So now is we are discussing about of the transport number. So transport number is, so let's say that ions, due to movement of ions, current is produced. So now here the ions for these solutions, Na and Cl minus are the ions. So now if anybody asks us that what is the current that is produced due to Na plus ions, or what is the current produced due to Cl minus ions, on that case we said that due to Na plus ions, amount of current produced, so that is called transport number. Transport number means due to these ions, individual ions, how much current is generated, that is called transport numbers. So due to Na plus ions, these ions, individual Na plus ions, how much current it can carry, that is called transport number. If I say in local language, so due to Na plus ions or Cl minus ions, so individually if you ask that what is the current carried by Na plus, then I say that how much current it can carry. carry by moving of Na plus ions. So transport number so the definition here is the total fractions of current carried by an individual ions. So due to individual ions, how much current will carry? So you know that current is produced due to the movement of ions. So if current is produced due to movement of ions, then our questions will be, here the ions for these solutions are Na and Cl minus. So if we simply ask that what is the current produced due to this movement of Cl minus ions, because you say that due to movement of ions current is producing. So if anybody asks you that what is the current is produced by the movement of Cl minus ions, so that current due to carried by Cl minus ions, that we express in transport number. So current so now the current carried by cations will be what, that current carried by cations is equal to that we express in transport number. So transport number of cations is equal to current carried by cations upon total current carried by all ions. Okay, so current carried by cations, that is equal to transport number of cations. So transport number, what we say, the transport number we express for calculating the individual current carried by cations or ions. So what you say, that due to N plus ion, how much current it can carry by moving by the movement of ions, movement of cations. So that is known as the transport number. So if anybody asks that due to these cations or these ions, how much current it able to carry, so that is called the transport number. So transport number means, what? Actually transport number, here we are calculate that how much current carried by these cations, how much current carried by this anion. So that we expressed in a terms that is known as transport number. Transport number that is expressed, so this represent as T. So this transport number is expressed by T, and that is the total fractions of current carried by an individual ions. So I think you get it. Means try to understand, make the point clear. That means the questions arise that due to movement of ions, current will produce. It means that whenever if the ions move past, then it able to carry more amount of current, means more current will generate. Okay, after that, So if we see in this experiment, I have so many ions are there, and the NCl minus ions are there. Now the questions ask that how much is current is carried by Cl minus, or how much current is produced due to the movement of Cl minus. So for that, individually we are asking only Cl minus or only Na plus minus. On that we express in the term of transport number. It means due to this how much current it carried. So let's say Na, let's say Na ions. So due to this movement of ions, how much it current carried? So that we expressed as due to Na plus ions, how much current it carried? That we express as current carried by Na plus upon total ions present. That is current carried by Na plus current carried by Cl minus. So this we give the new terms that is called the, so this is what, due to movement of Na plus ions, how much current it will carry, how much current it carry. So this sentence we give that new terms, that is transport number. Okay, so that transport number we represent T, and we write that T Na plus, because we have to write this much of sentence. So for that we give the new terms, that is transport number. Okay, so that transport number equal to current carried by these cations upon total current carried by these ions present in these solutions. Okay, so that's we give the total fractions of current carried by an individual ions or current carried by cations is equal to Ta plus current carried by cation upon total current carried. That means, let's say cation I'm taking positive, then current carried by this cation upon current carried by cation plus current carried by anions. This is called transport number. Okay, so now that this question is what is the so what is the transport number order of this? So if he says that here in a solutions, so I will erase it. Let's say if there will be a competitions, let's say we have Li plus, Na and K plus is there. So in between that, whose transport number is high, then I will say the transport number means number of, so transport number of this Li is high or Na is high or K is high. If the question is asked whose transport number is high, so let's say Li means this should be with some it's onion also there, it also onion also. Let's say I'm comparing with Na plus and K plus. So let's say in the solutions, let's say NaCl we have one electrolyte and we have the KCl we have the two electrolytes. So whose transport number is high? Transport number Na is high or transport number K is high? So in the solutions, let's say here I have NaCl, let's say here I have KCl. So this NH plus and Cl minus, this K plus and Cl minus, so they has to, this is negative, this is positive, this is anode, this is cathode. Okay, and this is anode, positive, positive, and this is cathode, negative, negative, negative. So this Na plus get attracted to here, this get attracted to here, and this get attracted to here, this get attracted to here. Now the question is which transport, I am comparing the transport number of Na plus and Ka plus. Transport number of Na plus is high or transport number of K plus is high. So I say that this NaCl will move to here, so whose speed is high? That is the first questions. So because we are dealing with Na plus, Cl minus is there, Na plus is there. Here K plus, Cl minus, K plus, Cl minus is there. So there at, so we are just wants to know that whose speed is high. So according to the speeds, we know that hydrated speeds, we know that K plus is, here we already discussed that hydrated speed, so hydrated radii will be this, so ionic mobility K is greater than Na. Now the question is what, now so current production is this. Now the question is transport number of whose is high, this or this. Okay, that is the questions. So let's say speed of Na plus is, let's say 10 meter per second, let's say, and speed of Cl minus, let's say 5 meter per second, and here let's say speed of K. So here we have already discussed that this is more than this, so ionic mobility of K is greater than this, so I take K is high value, let's say this is 15 meter per second, and speed of Cl means this is 5, so I again have to write 5 meter per second. Then the transport number is transport number of Na plus. Transport number Na plus means this upon total, that I write. Transport number of Na plus means that is ionic mobility or current carried. So here ionic mobility, this, or speed, this upon Cl minus. Similarly here transport number of K plus is ionic mobility of K plus Cl minus. Okay, so here that transport number of the ionic mobility of Na plus is 10 meter per second, so 10 and upon 10 plus 5, and this is 15, so 15 plus 5, because both sides, this is Cl and this is Cl. So whose transport number is more? So transport number, this is 10 upon 15. So if we divide it, then this is, that is equal to 0.66, and here transport number of K plus, that is commutative 15 upon 20, that is 3 upon 4, so that will be how much? Sorry, so this value. So we see that if the, so we see the transport number of Na plus is great, transport of k plus is greater than transport number of na plus. With this, so this value is greater. So similar to that, if the ionic mobility of Ka plus is more, then transport number of this K plus is also more. It means transport number of K plus is more than transport number of Na plus. Similarly, it is more than transport number of M plus. Okay. So you understand that what do you mean by transport number? Transport number is actually the fractions of current carried by an individual ions. Means if the current carried by, if we ask anybody what is the current carried by this, simply Na plus ions, then we calculate that current carried by this upon total ions, current carried by total ions. So transport numbers, we see that is fractions of current carried by individual ions or in the solutions. So transport number of cations is equal to current carried by cations upon current carried by cations plus current carried by anions. Similarly, transport number of ions is current carried by ions upon current carried by cation plus current carried by ions. So also we know that Q equal to IT, then I equal to Q upon T. So in the I if I put Q upon T, then transport number of cations equal to Q upon T, and for cations I write positive and transport, and here again, since the experiment will happen at the same time, so time both the cases is equal, so transport number of cations is equal to Q so this cancel, so this is going to be transport number of cations equal to Q positive. Similarly for anions it will be okay. So similarly way that this is directly proportional to I current carried by ions, or it says that from here we see that current carried or ionic mobility, they are same way. Like if we say ionic mobility is increasing these sides, then current production also increasing this side, means current carried is directly proportional to the movement of ions. Hence ionic mobility means current carried by ions directly proportional to mobility of ions. It means I can write current carried by ions, current carried by any cations is directly proportional to mobility of that cations. So if I said cations, if you remove the proportional constant, that I will put one constant, then this upon this. So transport number is any cation is this upon this. Cation plus ions, and this is directly proportional to this value. So here also I can write K upon so the proportionality constant will be removed because both sides will divide, so that I will write directly Since this is directly proportional to this, so this also we can write transport number of cations is equal to mobility of cations upon mobility of cation plus mobility of ions. Similarly, transport number of ions is mobility of ions upon mobility of ions plus mobility of cations. Okay, so how many relations we got? One relations with current, transport number with current, and transport number with charge, and transport number with mobilities, and also the transport number of, also the conductance is directly proportional to mobility of ions. If mobility of ions is high, then high conductance. So mobility of ions, and conductance we say that, let's say m infinity, this is equal to of any solution A B, then what we write is that infinity of A minus. So this conductance is directly proportional to this, so this one also I can write that transport number of cations is equal to ionic conductivity of any cations upon this ions. This also the relationship, also T minus equal to this one. Also the relationship with speeds, so that is directly proportional to the speed, so I can write B velocity of cations upon velocity of cations plus velocity of ions, or so these are the whole relationship with respect to transport numbers. So in combine, if I write, then transport number of cation is to current carried by cations upon current carried by cation plus carried by anions. This also right, and this is also equal to ionic mobility of cations on ionic mobility of cations plus ionic mobility of ions. This also right, and so this also right. Also velocity of cations plus velocity of ions, this also right. Also this, so this whole things is also right with transport number. Similarly, for transport number of ions is similarly sorry similarly for ions also. So this is the relationship between with transport numbers, with currents, with ionic mobility, with ionic conductivity, with speeds, and with charges. So this relationship only you have to remember for the transport number. So what is the relationship between transport number of with this one, with this one, this one, with this one, and with this one. And the last terms, that is ionic mobility at infinite for any cations is directly proportional to that is ionic conductivity at infinite dimensions of cations upon charge into Faraday. So this represents the charge of cations or anions. So for anions, if I write, that is become and F, where and F is 96500 coulomb Faraday. Okay. So this relationship also you have to remember. Ionic mobility of at infinite dilutions of cation is equal to ionic conductivity of cations at infinite upon Z into F. So this Z is charge of cation or cations and F is 1 Faraday. Also ionic mobility of cations at any concentrations is equal to ionic mobility ionic conductivity upon B upon L. This is speed, and this is potential difference. So this upon this one also you have to remember. And if potential difference upon L length it is actually called gradient, and maximum time this gradient equal to 1, then ionic mobility at any concentrations of cations equal to speed of the cations. Okay, so this much is enough for the transport number. Okay, so this the relationship we have to remember transport number, and we have to understand that what do we mean by transport numbers, why transport number term such comes, what is actually mean by transport numbers, so that we explain. So today after this, thank you.